Let's think about the fronts a little bit more. We said cold fronts happen when a cold blob of air is pushing into warm air that's already in place, and the warm front happens when a warm air is coming in into a place where there is cold air and high pressure already in place. So typically what happens is because you are mixing cold, dry, high pressure air with warm, moist, low pressure air, you end up with very sharp fronts, and you develop storms at these places. The scales are different, as we said. Warm front has a larger scale than a cold front, but nonetheless, places like, for example, the east coast of the U.S., where you have the very warm Gulf of Mexico sitting to the southeast, and you have sometimes cold air coming behind the jet stream as the jet stream dips in. And if there is a rush of warm, moist air from the Gulf of Mexico and they meet someplace over, let's say, Washington, D.C., you're going to have lots of thunderstorms, snowstorms, sometimes thunder, snow, and so on and so forth. This is very typical of the storms. We mentioned how the upper branch of the Hadley cell, Ferrel cell, and so on are affected by the Coriolis, and they have to turn east because they are going north to the right of the direction of motion. So this ends up with these narrow, fast-moving air in the upper atmosphere, about 6 to 10 kilometers, depending on 6 to 8 kilometers, depending on whether it's the subtropical jet stream or the polar jet stream. And it is narrow in its dimension. It's like almost like a pipeline, very rapidly moving air at 200 kilometers per hour or so, and it's an easterly flowing air, which means it's going towards the east. Remember, we said westerly winds means winds are coming from the west. Easterly airflow means it is going towards the east, so don't confuse the terminology here. So at mid-latitudes, the winds at the surface are westerly, and the jet stream is westerly, which means you have a structure that is very favorable for the jet stream to have these rings and eddies and waves which can come down to the surface. So that means the unusual weather at the surface can be caused by the steering of the air masses by the jet stream, right? We saw a map of various air masses over the US, and this happens on Europe and parts of northern Asia as well. So this wobbling of the jet stream creates cyclonic and anticyclonic circulations on the surface, which is the weather we experience. So we typically say jet stream can put down weather because it is moving a very fast moving air with a lot of wobbly behavior, rings forming and eddies forming. We have not defined eddies, but I think you have some idea. You can Google and find out. So this is something we have to remember. The atmosphere can move fast, and it can have fronts, and it can have fast developing storms, etc. We'll see later on that ocean also tends to have fronts and storms, but ocean in general moves very, very, very slow compared to the atmosphere because it's very high density and cannot move very fast compared to the air, which is very light. So let's stop this one here and look at hurricanes in the next